Using the best welding method for an application increases the likelihood of a strong, durable, and defect-free weld. In some cases, the welding method is specified, and in other cases it is left up to the welder. Welds should be made according to the specifications on the welding drawing. Welds are visually inspected and sometimes physically tested to ensure that the weld will perform its intended function. Visually inspect all welds for quality. The weld should be clean with no pits or color spots on the surface. This indicates proper gas shielding. Verify that there are no distinct edges between the base metal and the weld bead. Distinct edges can indicate poor fusion with the metal. Also, check for spatter, sometimes called weld berries, around the bead. These are signs that the welding machine settings were not adjusted correctly and that the weld quality is poor. The weld bead should have a consistent size and appearance. A good weld has even ripples that looks like toothpaste squeezed from a tube. A sloppy, uneven-looking weld could be a sign of flaws within the weld. The weld should have the same width and height all along the joint. Varying bead width can indicate an incomplete bond between the two pieces of metal. Inconsistent bead height indicates varying degrees of penetration. Welding drawings often specify the penetration depth for fillet welds. Penetration indicates the depth at which the weld melts the base metal. A weld must have ample penetration so the joint will be strong enough to perform the job it is meant to do. Proper penetration is a major factor in making a good weld. Groove weld penetration should generally be 100% and is checked by turning over the welded metal and looking at the opposite side. The other side should have a discoloration of the metal where it was affected by the heat. Also, check to see how much of the melted metal protrudes from the groove. The protrusion should be slight, between 3/10 millimeters or 1/64 inch and 7/10 millimeter, or 1/32 inch. If the melted metal does not protrude from the groove, the filler metal did not penetrate enough. Welded parts should have good fusion. Fusion refers to the atoms of each piece of metal bonding together to become one solid piece of metal. Complete fusion is always required to get a strong, durable weld. Good fusion takes place when atomic bonding occurs on all surfaces of the welded joint. There should be no gaps or holes in the weld. Incomplete fusion occurs when the filler and base metal do not melt enough to become one piece. The filler metal only partially bonds to the base metal, causing a very weak weld. Poor fusion is indicated by a visible gap between the bottom of the weld and the base metal. The size of a weld is typically specified in a welding drawing. The welder should use this specification when making the weld. The specified weld size is often determined by testing to make sure it provides the needed strength for the application. If the weld is smaller than specified, the strength of the weld may not be sufficient. The weld size should not be greater than the size of the effective throat. A weld that is larger than needed is a waste of filler metal. In welding, when is complete fusion required? Fusion refers to different elements coming together in a union. In welding, complete fusion is always required. Complete fusion occurs when all surfaces of the welded joint fuse together as one.